SpaceX just cracked the code. After Ship 36 exploded, they discovered something incredible. The carbon fiber tanks everyone thought were cutting edge, they're actually the weakest link, failing at 70% when they should handle full pressure. But here's the genius part. SpaceX isn't trying to fix them. They're ditching them entirely for simple, all-metal tanks. Why would going backwards to old-school metal be the breakthrough that saved Starship? And how does this explosion actually clear the path to Mars? The answer will blow your mind. Let's dive right in. The night everything changed, June 18th, started like any other test day at Starbase. Ship 36 sat on the test stand, gleaming in the Texas heat. Engineers ran through their checklists. Everything looked perfect. Then, 11 p.m. hit. The propellant loading began. Super cold methane and liquid oxygen flowing into the tanks. Standard procedure. They'd done this dozens of times before. But something was different this time. Deep inside Ship 36's nose cone, a ticking time bomb was about to explode. The composite overwrapped pressure vessel, let's call it a COPV. These aren't your typical gas tanks. We're talking about vessels wrapped in thousands of carbon fiber strands, engineered to store gases at crushing pressures that would flatten a car. Here's where it gets terrifying. This COPV failed at just 70% of its rated capacity. Let that sink in for a moment. It's like a bridge collapsing under half the weight it was designed to carry. This wasn't supposed to happen, ever. Yet here we are, watching SpaceX turn this disaster into their greatest breakthrough. When 100 million becomes fireworks. When that COPV let go, it didn't just pop like a balloon. It unleashed a chain reaction that turned cutting-edge engineering into scrap metal in seconds. The explosion was so violent, it completely destroyed the test facility. The static fire test stand? Gone. The methane tank farm? Obliterated. The intricate network of fuel lines that took months to install? Vaporized. But here's what makes this even more shocking. SpaceX has been using similar COPVs in their Falcon rockets for years, without a single failure. So why did Starship's version suddenly become a death trap? The answer lies in a detail most people missed. SpaceX employees had been raising red flags about COPV handling in the Starship program. Word was getting out, these pressure vessels were being mishandled during transport and installation. Carbon fiber might be incredibly strong, but it has one fatal weakness. If even a few of those thousands of microscopic fibers get damaged, the entire structure becomes compromised. It's like pulling a single thread from a sweater. Everything unravels. Was this explosion really a manufacturing defect? Or had SpaceX been cutting corners in their rush to reach Mars? The truth is about to shock you. The decision that stunned the industry. Here's where the story takes an unexpected turn. Instead of panic, instead of delays, SpaceX made a decision that stunned the aerospace industry. They're throwing out the entire COPV concept. Elon Musk himself confirmed it. They're switching to all-metal pressure vessels. No more carbon fiber, no more composite wrapping. Just solid, reliable metal. But wait, doesn't this sound like going backwards? Every modern spacecraft uses composite materials to save weight. Weight is everything in rockets. Every extra pound costs thousands of dollars to lift into orbit. So why would SpaceX deliberately make their rocket heavier? The answer reveals something profound about how they think differently from everyone else in the industry. And it's about to change everything we know about spaceflight. The Mars math nobody talks about. Here's the secret SpaceX doesn't advertise. For their Mars mission to work, they need Starship to be practically bulletproof. Not just safe, bulletproof. Think about it. When you're launching dozens of Starships in rapid succession, loading them with fuel in orbit, and sending them on 6-month journeys to Mars, you can't afford mysterious failures. You can't afford components that fail at 70% capacity. Every single system has to work every single time. This is where SpaceX's move fast and break things philosophy hits a wall. You can break things on Earth and learn from them, but once you're committed to Mars, there's no going back. There's no rescue mission. There's no second chance. The all-metal solution isn't just about fixing the COPV problem, it's about fundamentally changing Starship's DNA. from a prototype into a production vehicle, from a test rocket into humanity's lifeline to another planet. But this decision comes with a price that could bankrupt the entire program, the hidden cost that changes everything. The explosion didn't just destroy Ship 36, it wiped out Starbase's primary test facility. The static fire stand that took years to build? Gone. The methane storage system? Destroyed. The flame trench designed to handle Starship's massive engines? Heavily damaged. SpaceX now faces a choice that could define the entire program's future. Do they rebuild the current test site to handle the remaining Block 2 Starships? That means spending months reconstructing everything just to test vehicles that will never fly operational missions. Or do they skip straight to building facilities for Block 3, the next generation Starship that's supposed to use these new all-metal systems? Here's the kicker. Choosing Block 3 means abandoning 2 nearly complete Block 2 Starships and roughly 100 Raptor 2 engines. We're talking about hundreds of millions of dollars in hardware that would never leave the ground. What would you do? Salvage what you can or bet everything on the future? The answer SpaceX is choosing will blow your mind. The challenge that terrifies NASA. Even if SpaceX perfects the all-metal tanks, they still face an engineering challenge that's never been solved. Refueling in space. A Mars mission requires more propellant than Starship can carry at launch. The solution? Launch multiple tanker Starships, dock them in orbit, and transfer fuel. It sounds simple on paper. In reality, it's terrifyingly complex. You're trying to pump thousands of gallons of super cold liquid fuel between 2 spacecraft traveling at 17,000 miles per hour. One mistake, one leak, one unexpected vibration, and both vehicles could be destroyed. NASA has never attempted anything like this. The Russians haven't either. The Chinese haven't even tried. SpaceX is essentially trying to solve one of spaceflight's most dangerous puzzles, while simultaneously redesigning their entire rocket. But that's not even the scariest part. The production revolution nobody sees coming. Here's the twist that changes everything. SpaceX isn't just building a rocket. They're prototyping an entire production system. Their goal isn't to build one Starship, it's to build 1,000 Starships every day. This explains everything that seems crazy about their development process. The constant explosions, the scrapped launch pads, the abandoned ocean platforms. It all makes sense when you realize they're not just testing rockets. They're testing manufacturing systems. The all-metal tank decision isn't just about safety, it's about mass production. Metal pressure vessels can be manufactured quickly, tested reliably, and replaced easily. Carbon fiber requires specialized facilities, lengthy curing processes, and expert technicians. When you're planning to build 1,000 Starships, simplicity beats sophistication every time. But there's a problem SpaceX doesn't want to talk about: the Starbase trap. Starbase itself might be holding them back. The entire facility is built on a small island in Texas. Everything is packed together: the launch pads, the fuel farms, the production facilities. When Ship 36 exploded, it didn't just destroy one test stand, the blast damaged multiple systems across the site. Traditional rocket programs space everything far apart for exactly this reason. When something explodes, it doesn't take everything else with it. SpaceX's rapid-fire testing philosophy works great until one failure cascades into a facility-wide disaster. Now they're learning that lesson the hard way. The question is, will they rebuild smarter or just rebuild faster? Line that compounds the cheers about a launching in Satiri, and only this longshoes along Antenthety's discussion in the die being a private chambier, nature, a Montuimurian Westerzen, that the latest to combined in Jesus abration services. New Year need to take a Montuimurian Westerzen that this experiment was trying through to deep day, the great longshoes and not having powerful direct to the resets are created. Being the world real in breaks in the ants, this is longshoes the typements on the automatic that longshoes is landed. Selective challenge, then in should go into in the game of your longshoes, be against of longshoes and they're good on place to create an why all metal changes everything. So why is SpaceX so confident that all metal tanks solve everything? The answer lies in decades of aerospace history. Metal pressure vessels have been flying in space since the 1960s. They're proven, reliable, and well understood. When they fail predictably. More importantly, they're maintainable. You can inspect metal tanks with simple tools. You can repair small damage. You can predict their lifespan based on testing. Try doing any of that with carbon fiber wrapped around a complex geometry at cryogenic temperatures. It's nearly impossible. The all-metal solution isn't just about preventing explosions. It's about creating a space-worthy pressure system that can be maintained, repaired, and trusted for years of operation. For a Mars mission lasting years, that reliability is worth every extra pound. But this raises the ultimate question. Final verdict. So here we are. SpaceX just turned their biggest disaster into their smartest move. By ditching fancy carbon fiber for simple metal tanks, they're not going backwards. They're going forward with confidence. Sometimes the most revolutionary choice is choosing reliability over innovation. Sometimes the path to Mars requires taking a step back on Earth. But here's what really gets me excited. This explosion didn't just reveal a weakness, it revealed SpaceX's true superpower, their ability to pivot faster than anyone thought possible. While other companies would spend years in committees, SpaceX is already rebuilding. While others would play it safe, they're betting everything on Block 3. That's the SpaceX difference, and that's why they're still humanity's best shot at becoming a multiplanetary species. What do you think? Is this bold move genius or madness? Drop your thoughts below, because this debate is just getting started, and if you want to stay ahead of every SpaceX breakthrough, every explosion, every pivot that changes everything, hit that subscribe button. Because at Space Corps, we're not just watching history unfold, we're decoding it before it happens. The journey to Mars just got more interesting. See you in the next one. Starship's ninth flight crashed because of one critical problem. Its attitude control system failed completely. The ship tumbled out of control and was lost. But that crash just revealed SpaceX's most brilliant solution yet. They're switching to hot gas thrusters. Why does this matter? These new thrusters are 5 times more powerful and don't depend on main tank pressure. When 2 starships need to dock in orbit for refueling, this is what makes it possible. But here's the real question. Can this same system get us to Mars? Let's dive right in. So what really went wrong during that 9th flight? The answer reveals everything about why this breakthrough matters. The moment everything went silent. Picture this: Starship is cruising through space at 17,500 miles per hour. Everything looks perfect. Then, a tiny leak begins. Just a small breach in the propellant system. But in space, small problems become deadly fast. As the leak continues, main tank pressure drops. The attitude control system, those crucial thrusters that keep the ship stable, they need that pressure to work. No pressure, no control. It's that simple and that terrifying. During re-entry, when precision matters most, the thrusters went silent. A 250-ton spacecraft started tumbling like a broken toy. The crew would have felt completely helpless. The ship was lost. But here's what SpaceX discovered from that disaster. The current system has a fatal design flaw that no one saw coming. The shocking truth about current technology. Every spacecraft needs attitude control. Think of it like power steering in your car. You can't drive safely without it. Most use something called cold gas thrusters. These systems are basically fancy compressed air cans. Simple? Yes. Reliable? Usually. Powerful enough for a Mars rocket? Absolutely not. The numbers are brutal. Cold gas thrusters deliver 50 to 70 seconds of specific impulse. That's like getting 20 miles per gallon when you desperately need 100. For tiny satellites, this works fine. For Starship, it's like trying to steer a freight train with a birthday candle. SpaceX knew this. Back in 2021, Elon actually announced plans for methane oxygen hot gas thrusters, real rocket engines for attitude control. The performance would be incredible. Then something strange happened. Those plans vanished overnight. No explanation, no updates, just gone. What made SpaceX abandon a superior technology? The answer connects directly to what happened on Flight 9. The elegant solution that became a death trap. Instead of hot gas thrusters, SpaceX chose something called ullage venting. This system is actually brilliant, until it isn't. Here's how it works. Cryogenic fuels naturally boil off as they warm up. This creates pressure in the tanks. SpaceX takes this escaping gas and channels it through nozzles for attitude control. It's elegant engineering. You're using gas that would escape anyway. No separate fuel systems, no complex combustion chambers. Even